Hello all, myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we'll discuss some programs which are there in question bank, and based on question bank programs based on second module, that is control structures. So we'll see what is control structure. We have seen, you can go through my previous video lectures based on control structures. So in control structures, mainly we have three types of control statements. First one is loop control statements, or loop statements. You have loop control structures. Next one is, second one is decision making statements. And then third one is, last one is jump statements. So in the category of control statements, we have these three different statements: looping statements, then decision making statements, and lastly we have the jump statements. So we are going to discuss the programs based on these different statements. The first program is as you can see here, this is the first program. So I'll read the statement here. A character is entered through the keyboard. So we have to write a C program to determine whether the given character or entered character is a capital letter or small case letter, a digit, or a special symbol by using switch case. So this is the table which shows the range of ASCII values for various characters. Suppose the characters capital A to capital Z, so they have the ASCII value 65 to 90, and small case letters small a to small z, they have ASCII values in the range 97 to 122, and the digits 0 to 9, so they have ASCII values in the range of 48 to 57. So there are other special symbols also when we enter them as characters. So these are the different ASCII values. Now based upon this information which is given, so we will write a program. And suppose we enter the character A. So this A is to be read as the character. So we know that if this is a character variable which stores A, then it's based upon the ASCII value, we can determine whether the given character is capital letter, small letter, or a digit, or a special symbol. Based upon this, so character A is encoded as 65. So if we write the condition that, so CH is greater than, if it is greater than or equal to 65, and also CH value should be less than or equal to 90, so then the given CH value is a capital letter. So let's see how we can write the program for this. So first we have to include the header file, stdio.h header file. Then inside the main function we need to write the statements. So first line is, so we have declared a character variable CH here. Then there will be a message on the screen that enter a character. So after that, the value of the character, so suppose we enter the character A, so this is stored in the variable CH. So char CH is equal to, so at this location, so A variable is, value A is stored here. Then it will print this value. ASCII value of %C is %D. So this %C is a format specifier to print the corresponding character, and this %D is the format specifier to print the ASCII value of the given character. So next, if this condition, so we have written if else condition here. So by using this if else condition, so we have written the program. So if CH value is greater than or equal to 65, and also CH is less than or equal to 90, so these two are combined by logical AND operators, so then it is a capital letter. %C is a capital letter. So %C is a format specifier to print the character variable CH. So next, else if, so if this condition is not satisfied, then it will check this else if condition, and then here it will check whether the given character is a small case letter or not by using this condition. So these are logical operators. So this is relational operator and this is logical AND operator. If CH is greater than or equal to 97 and CH is less than or equal to 122, so then the given character is a small case letter, that is lowercase letter. Next, for the digits, in order to check whether it is a digit or not, if the entered character is a digit, suppose we enter the given character as 0, then this is to be printed as this is a digit. So then it is stored in the form of ASCII value in the computer. So we are checking with this condition. If CH value is greater than or equal to 48, so corresponding ASCII value of 0 is 48. So then this condition is true here. So CH is equal to 48. This is true. So therefore it will print that %C is a digit. Next one, for special symbols. So these are the ASCII values we have to compare with. If CH is greater than or equal to 0 and CH is less than or equal to 47, or CH is greater than or equal to 58, if CH value lies between, the ASCII value of CH lies between 58 and 64, or if the CH value lies between 91 and 96, or if the CH value lies between 123 and 127, then the given character, then the given entered character is a special symbol. Now let us, if we execute this program, these are the two test cases we have executed this program for. So in the first test case, suppose we enter the character as Z. Now CH has the value Z. So this is the character if we enter. Now it has the ASCII value of 90. So that ASCII value is printed here. And then from the given condition, so this CH value lies between 65 and 90. So therefore this is a capital letter. Next, if we enter some other character, like if we enter this as the symbol, then its ASCII value is 37. So this program prints the ASCII value also, and based on that ASCII value, so it will print whether it is the ASCII value of percentage is 37. Therefore it lies between 0 and 47. So therefore it says that it is a special symbol. So in this way we can write the program. Similarly, we can use switch case also to determine whether the given entered character is a capital, small case letter, whether it is uppercase, lowercase, or digit or any other special symbol. Now next we'll write a program in C to display the n terms of odd natural numbers and their sum. So for example, sample input output is also given here. Suppose we enter the input as input number of terms as 10. So display the n terms of odd natural number and their sum. So expected output is, so in the program the output is expected in this way. So numbers from odd numbers from, so there should be a count of 10 odd numbers and starting from 1. So 1 to 19 are printed. As you can see here, the first number is 1, second is 3. So total count is 10 here. So we need input number of terms are 10. So therefore 10 odd numbers are printed. And in addition to that, sum of these odd numbers is also to be printed. So it comes out to be 100. So that sum is printed. So let us see how we can write this program. So we have declared 3 integer variables I, n and sum. So we have assigned a value 0 to the variable sum. Next, it will prompt the user to input the number of terms. So based upon the values entered, the number of terms, so some value will be printed. Suppose we enter 10 here. So that value is stored in the variable, is stored at the address specified by n. So next, the odd numbers, this will be printed. So in order to display the numbers from, odd numbers from 1 to 10, so this is the logic we have written. Since we need to access each value from 1 to this n, so therefore we are writing for loop here, and simultaneously inside this for loop we are doing the sum of all the numbers as well as we are printing each number by using printf statement. So in %d is the format specifier to print the corresponding odd natural number. So suppose this is the first odd number. Next, second odd number is 3. So 2 into 1 is equal to 2 minus 1. So this is how we can write in order to find out this odd number, this is the logic we need to use. So second number is 2 into 2 minus 1, which is equal to 3. So next odd number is 5. So this comes out to be 2 3s are 6 minus 1, which is equal to 5. So in this way we can write this logic. So when I is equal to 1, first odd number is 1. When I is equal to 2, the second odd number is 3, and so on. So in this way, 2 into I minus 1, and then we need to add the sum of those numbers. So initially some value is assigned a value 0, and then sum is equal to sum plus. So this is nothing but sum is equal to sum plus 2 into I minus 1. So in the first iteration sum is equal to 1. In the second iteration sum is equal to, so previous sum value plus the new value. So that comes out to be 1 plus 4. In the next iteration it will be 4 plus 5, and so on. So at the end we'll get the cumulative sum of all the numbers, all the odd numbers from 1 to 10. So this is the end of the for loop. So if you write this printf statement, then each iteration, each value of every time the sum value will be printed. So that's why in order to avoid that, we are writing this sum, we can print the sum value at the end of the for loop. So sum of odd natural number up to percentage d terms. So here percentage d corresponds to n, that means the number of terms which we have specified, and this term percentage d, it specifies the sum. So this variable sum holds the sum of all odd numbers. So this is the input out. This is the output which is obtained. So when we run the program, so it will prompt the user to enter the number of terms. Suppose we enter 10 here. So this is how we'll get the output. So odd numbers are 1, 3, 5, 7, 9, 11, 13, 15, 17 and 19. And in addition to that, it will also print the sum of odd natural numbers up to 10 terms are 100. So you can give any other number also and get the output. So next program is, we'll write a program to find the LCM and GCD of two integers. So LCM is nothing but least common multiple, and GCD is equal to greatest common divisor. It is also called as HCF, that is highest common factor. Suppose we have two numbers 2 and 4. So we can find the LCM of these two numbers in this way. So LCM of 2 and 4 is 4. So this is the LCM. In order to find out the GCD, we need to find out the common factors. So common factor of 2 is, the factors of 2 are 1 and 2, factors of 4 are 1, 2 and 4. So highest common factor is 4 here. So in this way, so 2 is the GCD. So in this way, this is the program to find out the LCM and GCD of two numbers. So we also have the formula LCM into GCD is equal to number 1 into number 2. So product of two numbers is equal to product of LCM and GCD. So this formula also we are going to use. So first, in the first line, we have declared all the integer variables num1, num2, GCD, LCM. Remainder, this is the numerator and this one is the denominator. Next, it will prompt the user to enter the two numbers. Suppose the user is entering 12 and 24. So 12 is stored at the address specified by num1 and 24 is stored at the address specified at this particular location, that is ampersand num2. Next, numerator, we need to find out the numerator and denominator here. So for this we have written the statement. So this is ternary operator which we are making use of. So it is nothing but it is a replacement of if-else condition. So if num1 is greater than num2, then numerator is num1. Then numerator is equal to num1. So suppose this is num1, this is num2. So here if this condition is satisfied, num1 is the numerator. And then if it is not true, then numerator will be 24. Then denominator is equal to num1 less than numerator. So if it is true, then if num1 is less than num2, then numerator will be num1, else it is num2. So in this case, num1 is less than num2, that is number 1 is less than this number. So 12 is less than 24. So therefore num1 is the denominator variable is assigned a value of num1. So therefore denominator is equal to 12 here. So this is how we get the numerator and denominator. We compare the two numbers and which one is greater. So that is assigned numerator and the other one is denominator. So in that way also you can write. So in the next line we are finding out the remainder. So remainder is equal to numerator divided by the modulus of this. So we are dividing here numerator and denominator. Suppose we divide 12 by 24. So this modulus will return the remainder of this. So 24 divided by 12 is 0. So after that it will not enter this while loop. So therefore it will go to this condition. GCD will be equal to denominator, whatever denominator is there, and LCM is equal to num1. So 12 into 24, this divided by GCD. GCD is equal to 12. So LCM is equal to 24. So in this way, and in the next two lines, GCD and LCM will be printed. So GCD of percentage D and percentage D. So percentage D stands for num1, percentage D. This is the format specifier for num2 and this format specifier is for the result GCD. Then LCM, similarly here percentage D, this is corresponding to num1, this percentage D specifies num2 and here this is the format specifier for the LCM. At the end it will, so this is how we can run this. If we run this program, so and if you enter 12 and 24, so you will get that GCD of 12 and 24 is 12 and LCM of 12 and 24 is 24. So if we enter any other number, so which is not divisible, suppose we give the two numbers as 9 and 24. This is num1 and this is num2. So this is number 1, this is number 2. So here in this case, so there will be a remainder here. So when you divide 9 by 4, the remainder is 1. So therefore it will enter this while loop condition. So and then correspondingly numerator value is assigned to denominator is assigned to numerator, remainder is assigned to denominator, and again this step is carried out. So numerator is divided by denominator to find out the remainder. So this process goes on repeating until the remainder is equal to 0. Until the remainder is 0. This process will go on repeating till this condition is satisfied. Next program is to write a C program to find the largest of three integers. Suppose we enter three numbers 12, 20 and 2. So here the program is to find out the largest of three integers. So out of these three, the output should be 20 here. So 20 is the largest. So for this we can write this by using ternary operator. So we have taken 4 integer variables A, B, C and 1 is biggest. So it will prompt this line, enter 3 numbers, so that will be displayed on the console. Then by using scanf function, so we are reading the values of A, B and C and storing them at A is stored at this particular address, B is stored at this address and C is stored at this particular address. So here this is the logic to find out the biggest of 3 numbers. So you can write this by using simple if-else condition also, if-else statements also. So this is the other way we can write the program. So if A greater than B, then this is evaluated. If it is false, if this condition is false, then this statement is evaluated. Now suppose we enter these values. So here 12 is greater than 20. So this is false. So when it is false, so therefore this statements will be evaluated. Again it will check whether B is greater than C. So 20 is greater than 2. So this statement is true. So when this is true, so therefore B is the biggest. So biggest variable is assigned with the variable with the value of B. So in this way, when we run this program and the output will be, and if we enter these 3 numbers, so output will be 20 is the largest number. Next program is to write a C program to find the eligibility of admission for a professional course based on the following criteria. So based on the marks obtained in different subjects, so there are 3 subjects considered here. So first one is maths, physics, and the last one is chemistry. The condition to get admission in a professional course is marks in maths should be greater than or equal to 65, and here marks in physics should be greater than or equal to 55, and marks in chemistry should be greater than or equal to 50. And in addition to that, this condition also must be satisfied that total in all the 3 subjects, so marks in all the 3 subjects must be greater than or equal to 180. So, or the other condition is to get the eligibility of admission. So, this is the other condition, to total in marks and total in maths and physics should be greater than or equal to 140. Now, let us write the program for this. So, we need 3 variables here. So, in order to store the marks of maths, physics and chemistry. So, these are the 3 variables: maths, phy and chem. So, by using scanf function, we can read the marks of physics, chemistry and math subjects. Then this is the logic which we have written to check the eligibility condition. So, if maths is greater than or equal to, so maths is a variable which is used to hold the marks in maths subject. Next, we have a variable phy. So, this is used to hold the marks in physics, and which the other variable is chemistry. So, this is used to hold the marks in chemistry subject. So, suppose we enter this as 55, this is 76, and the last one is 66. So, here in this case, you can see that maths marks are greater than, so physics is 55. So, if we enter physics as 55, maths as 76, and chemistry as 66. So, maths is greater than or equal to 65, the condition is satisfied. Similarly, in physics, it should be greater than 55 or equal to 55. That is also satisfied. In chemistry, it should be greater than or equal to 50. So, that condition is satisfied. And also, in addition to that, this condition is also to be checked. Maths plus physics plus chemistry should be greater than or equal to 180. So, if we add all these 3 marks, so, and if the total is greater than or equal to 180, then it will be printed that the person is eligible for admission. Else, if it will check the other condition which is specified in the problem. So, total in maths and physics should be greater than or equal to 140. So, maths plus physics should be greater than 140. If this condition is satisfied, the person is eligible for admission into the professional course. Else, if both of these conditions are not satisfied, then the person is not eligible for admission. So, if we run this program and if we give the marks as physics marks as 55 and mathematics 76, and if we enter the marks in chemistry as 65 and find out the total, and so at the end we will get the result that the person is eligible for admission. So, if we give any other marks, so based upon this criteria, so the person can be eligible or cannot be eligible for admission. Next program is to compute and display the sum of all integers that are divisible by 6 but not divisible by 4. That means, so range of numbers will be given. So, range is given as 0 to 100. So, in this range, we have to find out the numbers which are divisible by 6. So, that means number mod 6 must be equal to 0. This condition you have to check also. And number mod 4 should not be equal to 0. So, these 2 conditions must be satisfied. So, when these 2 are satisfied, then the program should count and display the number of such values. It should count such number, it should give the count of such numbers, and also it should display those numbers. Let us write the program for this. So, here we have declared, we have assigned a value of 0 to integer variable lower limit. So, this specifies the range. This is the lower limit and this is the upper limit. So, 0 is stored in the variable lower limit, 100 is stored in the variable upper limit. Then we have a variable sum which is assigned 0, and also we have a variable count which is also assigned a value 0. Next, for loop. So we need to access, in order to iterate the values from 0, in order to access the numbers from 0 to 100. So we are writing for loop here. So for int I is equal to lower limit, I less than or equal to upper limit. So this loop will repeat from 0 to the last element 100. In each iteration, I value will be incremented by 1. So in the first iteration, I is equal to 0, next iteration, I is equal to 1, and so on till I is equal to 100. This loop will repeat. Now it will check in each iteration, I value will be checked for this condition, whether this condition is satisfied or not. So I mod 6 is equal to 0 and I mod 4 is not equal to 0. So if both the conditions are satisfied, then I value will be, so sum is equal to, sum plus is equal to, or you can write it as sum is equal to sum plus I. So this sum value will be updated. Value of I is added to sum, and also count also will be updated. So if this condition is satisfied, if the control is coming in this if condition, these statements, both these statements will be executed. Sum value is incremented, sum value is updated, and also count value is incremented. Next, at the end of this for loop, we are printing the sum of numbers which are divisible by 6 but not by 4 between %d and %d. This is the number to specify the lower limit, and this format specifies the upper limit, and %d is for giving the sum. It stores the value sum and number of such values. That means count is given by the variable count. So that is what we are displaying. Now if we run this program, then we can say that, so this is the output of this program. So when we give the upper limit, lower limit is 0 and upper limit is 100. So we can see that sum of numbers divisible by 6 but not by 4 between 0 and 100 are 384. So sum is 384. Sum is 384 and the count is 8. So there are 8 numbers in between 0 to 100 which satisfies the given condition. So in this video lecture, we have covered some programs based on which are given in question bank based on control structures. In the next video lecture, we'll discuss some more programs based on C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.